Okay, welcome everybody to the past seminar series. I think we are now recording. And to introduce our speakers, I'm going to hand it over to Justin Wiley. Justin.
Hey, thanks, Scott. And thanks everyone for joining today. I really appreciate it. We are excited to have Valtech here with us today. Valtech is a global innovation agency, and they're focused on developing business transformation through technology, design, and innovative experiences. We've been working closely with Gopi and Angela over the last month or two as it relates to work zone data exchange and some of the innovative solutions that they are bringing to roadways around the US and around the world. And so with that, I'm going to turn it over to our team at Valtech, to Gopi and Angela, to give their background and presentation today. So warm welcome to the Valtech team. Thank you for being here.
Thank you, Justin. Really appreciate that intro. Thanks, everyone, for joining. Thanks for your time. So, Angela, if you could start the presentation, please. And then, so I just introduce the topic, then we'll introduce ourselves and then go through the presentation.
All right. I believe I am sharing. Does everyone see?
Not the presentation. It's not. It's showing the code.
Oh, okay. Stop share. We'll try that again.
That's the code behind the material presentation. All right.
All right, let's see. This.
Yeah.
Yep.
Very good. Thanks, Angela. So we'll talk about the smart work zones today, how we are advancing the safety and mobility through use of the connectivity through these for these smart work zones. If you could go to the next slide, Angela. So today's presentation will tag team. Angela and I will tag team. Give the stage to Angela. Please introduce yourself, Angela, and then I'll go next. Thank you.
Great. Thanks, Gopi. Thanks, everyone, for having us today. I'm Angela Fessler. I'm Director of Engineering for the Safety and Mobility team at Valtech. We focus on enhanced safety and mobility through standards-based applications, adhering to standards such as Work Zone Data Exchange, SAE, message sets, and our mission is safer roads for all road users. It's good to be here, and I'll pass it over to Gopi with that.
Thanks, Angela. Hi, it's Gopi Surnilla. I'm working as a business development and tech strategy lead at Valtech. Before this, my life was virtually all my life was at Ford Motor Company. I was leading efforts in the connectivity, connected automated vehicles, and ADAS. And after that, I came over here helping the Valtech out in this domain. Okay, next slide, Angela. So we'll do a little bit introduction on the Valtech as a company, go through some work zone insight, challenges and opportunities. What are we trying to solve here, right? And connected work zone solution space. We looked at the industry and give some space on that. And then the architecture of the work zone, data exchange, and connectivity architecture itself. How are we delivering solutions? I'll cover those parts. Angela will cover the work zone solutions from Valtech, and then I'll end with the roadmap and we'll have questions. Okay. So Valtech is a global company. We have over 7,500 people in 25 countries, and it's close to $1 billion revenue, but it's right? So the key thing we are trying to do is deliver this end-to-end experience, and we pride ourselves as experience elevation. So we have all the capabilities in terms of the backend creation of the data to the backend systems to deliver the in-vehicle experiences. So I don't want to go through all those things, but we have every aspect of being able to deliver the experience. Right, and then we are across many verticals, right? Agriculture, health, right? And when I look at it, it almost feels like Matsushita Electronics for me, right? We are in various domains, but the domain we are talking about and the focus today is going to be on the mobility and automotive vertical. That's where we are in this group. And that in that group, we have over 650 people, technical, mostly technical members, right? And then those are developing the mobility solutions. We are in about 65 markets. Great thing I saw was like, we have over 40 million vehicles, connected cars with our software in it. So this was fantastic experience for us. So we have started with 98 and continuously has been expanding. And you see various OEMs and other companies we have been working with. And our group itself was actually called Tome Software originally, and then we were bought over by Valtech and merged into the big organization here. Yeah. So this one is right. It's a connected vehicle solutions is where we are delivering, and we have a lot of assets and platforms that have been developed that on which we are able to deliver solutions. With in-car experiences, remote and V2X services, this is huge too. Beyond car, all the applications, middleware, and the backend systems, right? This becomes a strong platform for us. And then this platform is where we actually delivered the traffic light applications and V2X applications for Volkswagen and Audi as well, right? Just an example, if you think in the V2X world. Okay. So let's talk about the work zone data, right? What's the problem we are trying to solve here? Angela, next slide, please. So I think the work zone data is generally after trying to do something with it, it's incomplete. Most of the time it's inaccurate, right? It's like, you say there is a work zone, we know that, we all experience that. Really, there is no work zone, right? Actually, or there is, don't say there is a work zone, but there comes a work zone, usually short duration work zones. And so that makes it very difficult to manage that data to be accurate. And especially for short and unplanned, it's really troublesome. So really we need to take, this calls for like effective connected work zone solutions. Connected because I think that's the one that actually helps us solve the problem. Why do we need to do that? I think this is mostly for safer roads for workers and drivers. Work zones are very dangerous zones. And for the mobility and traffic flow, really, right? I mean, work zones are really nightmare in terms of the traffic jams, both for customers and for the DOTs. They hate the fact that it's like, the traffic jams up. So to realize that really to improve these benefits, we need a data that is accurate and timely for the end users. It has to be real time. It has to be accurate. When you say something, you mean it and you got it, right? That's how people should get it. So for the drivers, all that work zone information translates into in-vehicle alerts, maybe, right? Provide information if there is a problem situation, whatever it is, right? Traffic jams, end of the queue, such information. And that information right into the mapping applications, right? I mean, this is huge, right? Apple and Google Maps, or even in-vehicle maps, right? Significant use of that. And we depend literally on that in terms of the digitally what's going on outside than physical boards. And then the signage, whenever we say, it's like, if there is an active work zone, it better be active work zone. There are workers in there. Most of the time we see that it's not true. So that's first one to deliver there. And then the other one is improve that information itself improves the analytics and monitoring of the work zones and worker safety, figure out ways to save workers from injuries. Okay. So we wanted to really understand the problem and talking to various people, but Volpe was the one actually did a very good job of talking with various DOTs, summarizing where the real problem was, right? It's like, there were a lot of feed issues. There's inaccurate data on the work zone begin and end states, simple begin and end states too. Active work zone information was very inconsistent. They say something, it's not true, right? No system is in place to using that data with cleaning up and transmit that information. There's no aggregation of the data from all the places, right? From multiple DOTs or maybe like municipalities and counties. One of the mapping companies was complaining is like, we say we direct the people based on some of this information and we direct them into another work zone, which was not known, right? So it needs to be integrated. Adoption wise, it's pretty expensive. Some of the solutions, what we were developing before, and they're not using work zone data exchange to transmit that information. And right, overall, it is getting a little cumbersome for them to manage that. And most of the DOTs are still using manual updates, which are not timely at all. So if you look at some of the insights we found, it's like, there are work zones, not all of them are dynamic. Counties, city work zones are usually dynamic. The DOT work zones are not dynamic, right? They're longer term work zones. So the customer does not get this comprehensive view of what's going on. And there is this feedback loop. It's interesting, right? We are saying this is the information DOT wants to transmit. And then actually the feedback loop is whether people are seeing and saying if it is true or not. We need to flip that. Provide the right information. You don't need a feedback on the system, right? And this low availability of this real-time information, right? People are not able to access it. Anyways, so this is with that low availability, actually mapping companies don't even want to trust the information. It's not accurate, it's not available comprehensively. So all these kind of issues we need to solve. And the connectivity was one of the things that actually providing real-time information that will help. Angela, if you could go next slide, please. So what's the current state? That's a lot of good progress has been happening, right? Millions of V2X messages are being delivered to drivers across deployments, right, through work zone data exchange. There are some movement is happening now. The work zone safety is gaining importance, right? There's a lot of the DOTs are talking about that quite a bit, primarily because the driver distraction has gone up, actually created the work zone as absolutely a dangerous spot now. And then also the vehicle automation is also calling for that. Not just level 4 kind of automation, even level 2s need that kind of information. Connectivity is becoming the central enabler for this, right? And so with that, there's a strong momentum towards finding solutions in that domain. And industry is also engaged, trying to deliver those kind of experiences to the in-vehicle. People are expecting and some demanding that they get such information in the vehicles. So, and work zone data exchange has been formalized now, so that hopefully will make some momentum. And there's a lot of standard bodies who are moving the needle in the standards and making sure we move towards agreed upon standards and make some dent. Angela, next slide, please. So if you looked at the solution space and then wanted to see, it's like, okay, where is it? Where do we need to go? And what are key attributes we need to think about, right? Angela, next slide, please. So this was the one that was done first, website updates, right? Mapping and saying where the work zone is and not. It's widely used by the DOTs. It's a scaled solution, interesting, right? But it's not. It's a low accessible. No one is going to go to the website and check that, right? I don't know if I ever did it, right? So it's scaled, not accessible solution. And it's not a ground truth. reality on the ground is not there. It's not updated real time. So it's used in long-term projects. That helps out, right? When we have 4 or 5 months or year projects. The second one is on the video image processing, right? This one, right, there's a lot of the vehicles have the video image processing, and then it's potentially able to use that information, right, to map out what the work zones could look like and provide that information back. But it has become expensive, really, for the equipped vehicles to be providing that information and for the DOTs to be buying that information to do that. Of course, it's not real time unless there is a mechanism that is stated to make it more real time. Okay. So some of the connected solutions space-wise, there were 2 categories. One is the dedicated cellular kind of devices. They have the GPS, they have everything in it, and they put the devices on that. And then the other one is the short-range technologies. So companies like Icon or Mac, they have developed that. And it's a dynamic work zone data, right? So it's good that way. But it is expensive because each device has their own data plan as current state, expensive. And the battery power consumption is pretty significant. So you have to charge it on a daily or a weekly basis, which makes it very difficult in terms of customer experience. Anyways, so Valtech has been focusing on the short-range technologies initially. So we'll go through some of those solution space. Angela, next slide, please. So if we looked at what are the key attributes that the solution needs to have to be able to be adopted and scaled, right? I mean, that our whole basis was looking around, just like, design the solutions, it has to fit these attributes, have to deliver to these attributes, right? So the attributes we deem necessary are the accuracy, they have to be accurate, solution has to be scalable, and low cost. These go together, really. If you make it low cost, then it's scalable, otherwise it's not. And it has to be user-friendly, right? Website was not user-friendly, but it's scalable, right? It's a scaled solution, so we can't do that. So it's like, no, you could go and update the website, right? So that's not user-friendly and not accessible. So we looked at the 4 categories that we talked, right? The website one, it's a low cost, but accuracy, and it's not user-friendly. And the video and image processing wise, right? The cost is high, accuracy is there, but not right away. It depends. Some of the initial accuracies were not there. User friendliness is the one that it's suffering at. And it's not a scalable solution at this time. Maybe it will change at some point. It is dependent on business models, actually, more than technical only solution. And then if you look at the dedicated cellular equipment, that's a back and forth here, right? Whenever we say some of these hardware cost, it's not a labor cost. If it's a hardware cost, it usually is on a ramp down, right? The cost will keep coming up. Hopefully change some of the dynamic. So at this point, the cost is a problem. It provides accuracy. It could be scalable because of the solutions. The user friendliness is suffering because you need to recharge those things. So if you come in the short range technologies, like where we are using UWB or Bluetooth stuff, where cost is generally very cheap, like tags and stuff like that, right? It's reasonably, the accuracy is algorithmically, we can make it good. User friendliness might suffer something, we'll talk about it. And then scalability wise, because all these things, tags and other stuff could be off the shelf parts, it could make it a scalable solution. Generally, principally, we were looking at Valtech as just like, hey, you want it to be scaled, then take off the shelf parts and put the intelligence in the software. That's the way we're going to scale and make it global, really, right? It has to be independent of country or cellular lines or whatever it is. We can scale it easier that way we are thinking about it. Next slide, Angela, please. Okay, so connected, the architecture wise itself, right? So all these connected devices to understand where the work, what the connected work zone is. These connected devices, we collect the data, send it up to in the cloud, and then send it to a work zone data exchange in the cloud. And then that information is disseminated to the third parties, right? To the maps and other companies. Or that in some ways, right? In the mapping is company mapping other websites they did manually, but we are trying to do this connected ways of doing sending that information. This is the architecture in which the way information is being sent out as the work zone data exchange. If you go to the next slide, Angela, please. So in this, right, it's not just work zone data exchange. Actually, V2X messaging about the work zones is also the other way, right? And so these connected devices itself, that data can go to the cloud, and we change that information into worker message, right? Traveler information messages or road safety messages. And these messages are sent out to the vehicles. There's a lot of talk about the roadside units, RSUs, V2X, whatever the PC5, 5.9 gigahertz, right? So that this information, connected data information, is sent to the roadside units to transmit to the vehicles. If the vehicles have OBUs, they receive that. Problem is actually RSUs are coming up, but OBUs are not there in the vehicles much. The other one is that same information delivered through network V2X UU. At Valtech, we are significantly focused on this part, right? Because I think that is because we can leverage the existing connectivity in the vehicles to deliver that information. Yep. Angela, next slide, please.
I see a hand up. Scott?
Oh,
I think you're muted. I don't hear you.
Cool. You can probably hear now.
Yes.
yeah, Scott.
Yeah, thanks, Gopi. Thanks, Angela. Just as someone who's not deeply immersed in the work zone data, can you give some examples of what some fields would be in the data? So I imagine you might have like a bounding box around the exact work zone. Maybe there's number of workers. Like, what specific fields of data might these include? Just help me understand what we're talking about here.
I'll let Angela speak to that one for sure.
Yeah, sure. Yeah, thanks for the question, Scott. So the work zone data exchange supports many attributes about the work zone. So does that TIM message and the road safety message. The TIM message is even more so than just work zones. But I'll talk about the work zone data exchange, which, as Gopi mentioned, has been formalized into the connected work zone specification. That includes different, they call them feeds, device feeds, which would be for connected equipment. And that could be for message signs, that can be for cones, that can be for lane markers. And I'm anticipating to grow the type of structures, the type of equipment that is identified within the connected work zone. It's also for road events, which are the entire work zone, and then that can be broken up into different road events. And each one of those will have a start and an end. And it could be that those are split by dates of when they plan to have that work executed. It also includes a start and an end time. So they figure the work zone might start at 6 a.m. and end at 8 p.m. And this is why it's important for us to get real-time data in there, because sometimes weather changes these. And if we're basing it only on what's been planned, we might not think that there are workers on site after 8 p.m. However, maybe something happened and there are still workers on site. That's why this connected equipment through those device feeds are crucial to enhance safety for these work zones. There are also, these road events might be distributed around curves and different aspects of the roadways, but bounding boxes are a common feature of that, and different locations from the work zone start to the work zone end. It also includes speed limits and reduced speed limits when the work zone's active. There is, and we can share this afterward, but there is a specification on all the different types of data that are included in the specification, shared in a GitHub repository out there.
Good. Thanks a lot, Angela. Scott, hope that answered the question, right? And the significant part most people would like is like, where does the work zone start? Where does the work zone end? Are the workers there? So I think that's one of the main elements, but it has all capabilities. Angela, next slide, please. So, and then take over. Thank you.
All right. So we'll just talk about a few of these solutions that we've been working toward at Valtech based on the history that Gopi just gave us. Thanks, Gopi, for that. So based on what we've learned and through our partners, we're executing different solutions to enhance safety in these work zones and improve mobility across work zones. And as we talk about the roadmap here, so this is very high level of what we've been looking at, what we've been working on specific to work zones over the past few years. We executed, and might have been a little before this, but worker presence for active work zone. As I mentioned, that's pretty important to know when workers are actually there, not the time that they're planned to be there, but when they're really on site. Afterward, we focused on connected first guard, so that's really making a cone that's in the work zone dynamic and be able to deploy it and generate that work zone feed automatically without someone having to type in information into a web interface. Connected Raptor, this is another project we work on to find locations of rumble strips. We're also looking at actively, we're working on Smart Barrel project. So going two different paths with this. One with GPS tags that are equipped on every barrel, and with a dedicated single LTE device in the field that will upload essentially those locations. And then in parallel, developing out a smart work zone using ultra wideband and Bluetooth mesh to localize the barrels with a single dedicated GPS and LTE device. And then the future, we see this as potentially going to tags with GPS and cellular on them, or potentially and using and leveraging those Find My networks out there, like the AirTags or the Samsung tags, and how Google and Apple out there can localize those for us, being able to leverage a system like that so we don't have to have this dedicated cellular device.
Yes,
So going back
to Peggy has a question.
Oh,
Peggy,
I'm sorry. Oh, Peggy?
Yes, thank you. So my question is, what is a smart barrel? Because I know for automated vehicle, there are this divider between, like say exit versus the main lane of usually on the freeway. That is one very challenging scenario for automated vehicle to navigate. And there are many related accidents have happened, not only in the US, but in many other countries. So is that smart barrel like, the yellow, very big thing that is between the divide, used as a divider? Or if that is the case, then this smart barrel need to be there all the time. So is that is my understanding correct?
So what we're looking at with this solution here is developing a device that can be put onto a barrel or be put onto equipment that can make that piece of equipment smart in a way that it's able to share its location. And then we're going through a couple different ways to localize these barrels, one being dedicated GPS and the other path using a single high accuracy dedicated GPS and using ultra wideband, which is also high accuracy, to localize those barrels. So these parallel paths are currently in development right now. And the idea is to get, I won't say lane level accuracy, but to see how accurate we are with these solutions. With the GPS system that we are using with corrections, the accuracy is quite good. And with ultra wideband, theoretically, the accuracy with that is quite good too. So we're looking forward to analyzing and seeing the results of this project.
Okay, so this, if it's for the smart barrel, does it has to be a work zone? Because like I mentioned, if it's a divider, then this GPS device need to be there all the time. Then there will be issues of battery charging, etc. So that's my question. But anyways,
So
Yeah.
Peggy, yeah, that's what we are addressing, right? It's a battery and other things. So even if you put a GPS unit and put the device there, we expect, we want it to be over a year worth of battery or something like that. So it's smart, and the other smarts are that you use the power less and all that stuff, and right, so it has to be accurate, but don't consume too much power. So those are the technology elements we are working through.
Okay, thank you.
Yeah, and then there's of course the opportunity for solar in there too, but we're looking with the software side, as Gopi mentioned, to have as few updates as needed. You leverage the components on board to see when we actually need to make updates, such as the IMU and those type of sensor detections. So the work zone data exchange, and at some point I'll need to update this slide to be connected work zone, but that was a recent update. So we are developing out a platform. We've got a platform and enhancing it to support the ingestion and the consumption from third-party devices to get data to and from that work zone data exchange. So in the center box here, we will be consuming data that's published to the system from device feeds, and that means connected temporary traffic control devices that essentially will have location, time associated with it, and we can map that to existing feeds and either augment that data with real-time information, or if there lacks, for example, a road event there, we can push that dynamic road event, which we'll go into in a slide, a couple slides ahead of here with the connected first guard. And these third parties are mapping providers. They could be dynamic signage. They could be OEMs looking for getting network messages to deliver to their drivers. They'll come to the system and be able to consume that data and deliver the appropriate messages to their users. We'll also still offer an interface for DOTs or fleet management to enter in planned work so that they can all go hand in hand. Planned work can be entered in if you're planning a trip ahead of time, be able to get information about planned work zones, et cetera, but really leveraging today's technologies to get real-time information into these feeds. With the system as well, it'll be deployable in a containerized environment. Google Cloud, AWS could be on the municipality's own server system. And with the system, it'll enable smaller municipalities, towns, and cities to also get involved with the work zone data exchange. So it doesn't have to be at such a high level of a state level because this will make it a scalable, deployable solution so that we can get information around the whole state and essentially around the whole country so that work zones, both planned and unplanned, can be taken into consideration when navigation is giving people efficient routes so they don't take someone off the highway back into a city that's under construction as well. With that, we developed a solution a few years back for worker presence. This was with our client and partner PSS. We took off-the-shelf beacon here and plugged it onto a vest, and we have a field device that can go on a vehicle. It's got cellular on it. It's got GPS. It can also just be a mobile phone here, and it's listening for this beacon. And this off-the-shelf beacon is configurable, so it can be configured to start transmitting based on motion, which is what we did for that. So if someone forgets their vest on site, it won't be transmitting all night, making it appear that there's a worker when there is no worker. So it uploads the cellular device, uploads this data to the cloud, and we take a look at work zone data exchange feeds that are out there and find one with a location that's mapping to this, and we're able to essentially say that that work zone is active. And third parties, such as mapping companies, dynamic message signs, the aforementioned, are able to take that information and deliver messages to their users that now have real-time information on the presence or lack thereof workers on site. So we did a presentation of this at ITS World Congress back in 2000, I think this was 2022. So we see there's a worker here. Once he comes to sign this dynamic message sign, it was reduced. I think for time's sake, I won't go into too much detail on this, but yeah, and I think we'll just talk through it because for me to get that video to play is probably not going to be timely. So this worker came up, it was 15 miles per hour, and it got reduced to 10 miles per hour. this person in the vehicle had a mobile application that has the library that we have on it, that has safety messages on it. It actually got this one over cellular, but there's direct messaging too, as Gopi showed that V2X. We've got a personal safety message coming across, direct, in this case, Bluetooth. And then we've also got network messaging coming across through WorkZone Data Exchange, talking about active work zone here. And we also, in this demonstration, demonstrated pedestrian alerts and cyclist alerts. So the presentation, that app that you saw there, integrated our library, which has features such as vulnerable road user alerting, being able to do different messages from and to vehicle, road and traffic management, and that library can stand as a standalone application like you saw there, or it can be integrated into existing applications or integrated into IVI systems or other backend platforms as needed. So with worker presence, we took it to the next step and said, hey, well, we need to know when work zones are there that aren't planned for, such as guardrail repairs, vegetation management, trimming trees, utility work. So PSS has a foldable cone, and we took that cone and triggered a Bluetooth beacon to be transmitted off of it when it was opened. So this introduced no extra work for the workers. We have an LTE device or a mobile phone, both. We've got both options there that listen for that and upload that data to WorkZone Data Exchange. And it does not look for existing feeds. It actually generates a brand new feed for it. So now we've got a feed in the exchange for this unplanned work that no one knew was going to happen. And third parties can continue to consume that data and deliver that messaging to users as they deem appropriate. So again, for time's sake, I'm not going to go into the video here, but we've got a dynamic speed limit sign here. Here's the IVI. This cone gets deployed here, and a WorkZone Data Exchange feed gets generated. We also have the worker presence here. So if someone puts on their hat, not only is the feed there, but now worker presence is true. And and then you close up the cone and the work zone goes away because work's done for the day. Oh, this is actually going to play. I did not mean to.
That's
Can you guys actually hear that? Did the sound come through on that? I did not expect the video to actually play.
We can't hear the sound.
Okay,
Sound is
I'm
not
going to
coming.
skip over that. Okay. I told you exactly what that video was going to tell you. So I think we should be good there. And I can send the link to that as well afterward. So smart work zones, this is where we're at today. We are looking to take this connected cone and working on taking it to the next level, where we're introducing ultra wideband so that we can localize each cone individually. So with the previous one, we have cones, you put the first one out, that's the work zone start, you put the last one out, that's the work zone end. And wherever the device is, that's where the location is. Well, we want to be able to localize every piece of equipment in the work zone. So we've got those parallel paths. One is where GPS is on everything, and the other is where we've got ultra wideband and a single GPS unit, and doing triangulation and localizing all of the work zone equipment that way. And again, we're going through the same path, identifying, in this case, we're actually taking it to the next level and saying, hey, are you a cone or what are you in the work zone? Are you the work zone start? Are you a cone? Are you a 25-mile-per-hour speed limit sign? And being able to deliver that very specific information via WorkZone Data Exchange for third parties to consume and deliver that experience that they want their users to have. And with that, Gopi, I think I will hand it back over to you if you want to cover the roadmap here.
Yeah. Surely. So this is our roadmap on the way we are developing the technologies, right? So first you saw the custom BLE beacon. So that was developing. It's like, hey, work zone is there, worker is there, right? Start work zone, worker is there, is the way it's there. Now you need to know exactly where those things are, right? That's where the aspect we are working on now. The project will be moving into testing phase in about a month. That one is like use off-the-shelf tags and be able to put all the work zone. I think, Peggy, you're interested in mapping out the whole work zone, right? you put the tags on, our system will be able to figure out all the localization for all the cones. You just go drop, 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 and then the cones, so that defines the work zone, right? We'll get to know what the accuracy is, right? It will be definitely lane level, but it is within the lane level, right? So, and then the other one we talked about is the GPS tag with the home base. GPS tag is figuring out the solution, location of the smart barrel, what we talked about, and that's communicating to the home base, and the home base sends the information over. This will be done, and then one of the things, the next phase we're looking at is the crowdsourcing of it, right? Take a tags from the bag of tags. I keep always calling it bag of tags, and go stick it on all the equipment, and then use the crowdsourcing to be able to localize those things. Especially this is cool for sidewalks and other stuff too, really. We put stuff and then people are walking around, that itself localizes. Lost bag, all these phones are like lost bags, and people using their network to do that. That's one thing. And then other one is there's a lot of development happening on the eSIM, and the data plans and the business models are evolving. And so if you use the GPS and LTE, those devices independently will be able to have smart cones. I expect that, right? The cost is unknown, right? As we put a gray on it. So as things come down, maybe we'll move into that space. One of the intelligence we are working on is how to manage the power and other elements, right? The data part is fine. Localization, we know accuracy. The power management is important. Say it's like, it has to 1 or 2 years. So that's the intelligence we are working in this space here. Okay. Angela, next slide. I think that's, thank you. We wanted to write on 6:50. We wanted to finish that up. So that's good. Questions? If you go next. Yeah. We still have 10 more minutes for asking questions too. Yeah.
So I have a question. I imagine in the near future, we're going to see a proliferation of connected work zone data, either in additional feeds, provided by you or DOTs or other companies. How do we understand that value chain, and how do we know which WZDX feed or CWZ feed is actually authoritative and the most up to date? Because I can imagine these things could overlap in very funny ways in the future.
Yeah. That's a great question, and one that we've thought about. And I think that the state level feed will still be the go-to, and they will vet which device feeds they ingest into their feeds. And then when the third parties, there is a Workzone Data Exchange registry right now. There are 29 states. There's a couple of off-state entities that produce data for that as well. But I see it still being similar to that, with the propagation of data from municipalities and cities going upward to the state level. And maybe at some point, all the states will go up to a national level. But I think it would be state by state and municipality by municipality vetting the equipment, the device feeds that they're consuming for validity before ingesting it into their own feed.
Yeah, Angela showed that work zone data exchange. One of the things that we are working on with the state DOT and the university is actually developing the framework where all municipalities, everyone can feed into one work zone data exchange for the state. So there will be 50 states. 50 is not as bad as actually having multiple municipalities having their own work zone.
Okay, so that's cool. So it sounds like you imagine, a state being responsible for, the work at some level, the work zone data within the state. I had this is sort of a detailed question. When it comes to things like speed limits and changing that speed limit, like who has the authority to do that? Is that the contractor? Is that the state? Like, is that something that gets prearranged? How do you imagine that working in?
Yeah, I mean, the speed limit has to be managed by the DOTs, not the IOs, right? They might put a requirement that the correct speed be displayed, but what speed, when it needs to be, all those are requirements from the DOT or MUTDC requirements, what they put it as, right? So what it needs to be is given, and it needs to be real time. That's where the problem comes in. And then this information needs to trigger that speed limits in there.
Thank you.
Yeah.
Al, do you want to jump in with anything? Because this is very much in line with a lot of the work I know we've been having a bunch of chats with Gopi and Angela. Thank you for presenting. But Hal, I just wanted to toss it to you because I know we're running low on time, but I look to you with some of the work zone stuff, obviously.
Yeah, obviously, I think what Gopi has presented here really complement with what we have achieved via our work zone data, especially since, as you mentioned, the video processing approach might be high cost, and we are actually trying to resolve this by using some low-cost sensors to enable crowdsourcing data and the video processing. But as you mentioned, none of the technologies can cover everything, every work zone. Definitely require combination of different approaches so that we can get a richer data set from different work zones. So that's something I was thinking about after seeing your presentation.
Yep. Thank you, Hal, for that thought.
I also have one question regarding the cost. So let's say Caltrans is going to deploy the smart cone. And what would be the cost difference for Caltrans? Let's say, what is the cost for each smart cone and the home base and other devices that are necessary? Because that will be also a question, Caltrans would definitely ask. Because I think for this work zone data, what we are aiming for is really to say deployment. Because, the technology, as you mentioned, you already doing some testing and, the work zone specification is already there in place. And Caltrans also have some existing, DOTs also have some existing, no matter it's a website or practices to update the work zones. So the next step, I don't think is going to have 2 or 3 years or 5 years of research. And we are really aiming for deployment. So what would be the cost difference for Caltrans?
So I think, because I don't know what the baseline cost is. I think our objective, right, when I stated in the beginning, it's like, these are the attributes we're working towards. We are going towards a low cost solution so that we can scale it, put the software intelligence in the backend. That's what we're going to do. So you have 2 solutions that we're working, Peggy, right? One was the tag with a localization, the smart localization that we're going to do. We will see the data and how it performs very soon in a couple of months, and also the smart cone. Right after that is where we're going to get to the pricing that product. That's what we are. Actually, we are in the place where we're saying what is it to the commercialize the product, whatever solutions we are coming up with, both the solutions. So we will have some, but it will definitely has to be much lower than where the existing solutions are, right? Like the cellular solution and other things that are there, with more improved accuracy. We have to improve accuracy and reduce the cost for its scaling. So will see that what that cost is going to come out to be. But if it's a tagging solution, definitely, right, it's going to be, we know what the BLE, UWB tags cost look like, right? They're pretty reasonable. So we put our software on it, whatever is needed to up power management and localization and other stuff. So we are going after that lower cost. So it should be good.
Thank you.
Yeah. And especially tagging, Peggy, We are not talking about, hey, where's the start, where's the end? We are thinking like, you know what, develop a solution which they put on every barrel, right? That's what it should go out.
Yeah, that's actually another challenging point is different kind of work zones, because some work zone could be over 300 meters. Will Bluetooth still work for those type of scenarios?
Well, we have
And
gone through that actually, right? 300 meters not a problem for Bluetooth. We have done extensive testing. Even I was doing testing. It's like 250 meters plus or minus, right? It's 500 meters is where Bluetooth covers it in the open. So that's not a problem. And then we have it's like if it's a home base, then it's a multi-home base, right? It's a half kilometer, every half kilometer it's another home base. That's what it's going to be.
great, thank you.
Yeah, absolutely.
Yeah,
Scott?
Gopi, Angela, thanks for the talk. Super interesting. I frankly have so many questions, but I'll just ask one. First, a quick comment on the previous discussion. I think the way to think about cost, it seems to me, would be for this technology, what is the cost as a percentage of construction and maintenance budget? Is it 1%, 0.1%, 0.01%, 0.001%? How many zeros after the decimal point? Is it for safety and saving lives? So I imagine that, from that perspective, it's, we have the technology to be able to do something. But let me get to my question. So context is, I teach a class called Design of IoT for Smart Cities. And so the technology that you described today is fully aligned with what I tell, 80 undergraduates to get in teams of 5 to prototype and make. So I think next round, I'm going to instruct them to try to do something related to what you're doing and ask you guys to come and judge them. But in thinking about the problem, right? I'm wondering how much of it is a technology problem and how much of it is a scalability or a scaling out problem. So that is, in your mind, when you think about where do we put Valtech's effort, where do you put your efforts? Is it more so, we need to solve the technical problem of, like Peggy was saying about, Bluetooth or some wireless communication technology at distance, or I think Angela, you mentioned a couple times, battery to support the sensors for a very long time, or do we basically have the technology to at least bound the work zone? And the bigger problem is just getting IOOs, DOTs, just all aligned to adopt this at scale. Like there's a simple solution that kind of impact, but getting it adopted at scale is more the problem. How do you think about where you put your effort?
I think they want to adopt at scale, and that means differently, right? They need to adopt at, hey, one barrel to say where it starts, where is the work zone, and when the workers are there. Key elements, important ones. Though for that kind of a thing, solution exists. The way we are looking at is, bring the solution that is not to the 5% of the rich population kind of a deal, right? Like, so it has to be equitable, which means we should bring a solution cost down, not just cost. It's not always the cost. It is to be user experience has to be brought down, and it has to be providing a benefit. Benefit keeps moving, right? Like localization. Okay, first I need to know that there exists. Then I need to know where exactly is the barrel. Then I need to know where exactly is the worker. Well, where exactly you mean? Where exactly in the lane is the worker? Where exactly in the lane is the barrel, right? So those are kind of the things that attribute benefits keep increasing, but we are there at a place where we say, this is where the work zone, this is where the work zone ends, this is where the workers are. Those are 3 elements. That technology is there. Where we are looking at is that technology also has to be cheap, and also we need to move the technology forward to give more and more benefits, because as researchers, we ask the question, right? Okay, if it was 5 meters accuracy, what can you do? If it's 1 meter accuracy, what can you do? If it's 2 centimeters accuracy, what can you do? Right? Automated vehicles will ask for 2 centimeter accuracy, right? Or 20 centimeters actually. So we are looking at a technology. You don't want to throw everything and start all over again. It has to be keep moving the same kind of hardware, but make it more and more intelligence to keep moving to delivering a higher and higher attribute benefit. So, right, so we are not just research, but research for a product. So, and the product needs to have some lifetime. So that's how we are moving. So that's our roadmap. We actually roadmap, if you look at the roadmap closely, we'll see it's like, why we are moving one step to the next step. We said, hey, home base. Next, we said, no home base, just crowdsource. Oh, home base is gone, right? So what do you mean? Just put the tag and you got it. So.
Thank you.
Yeah.
Okay. Any other questions? This is super exciting. Great conversation. Thanks for joining us, Angela and Gopi. Yeah, looking forward to more interactions. And thanks everybody for attending.
Same here.
Thank you both so much. And thank you everyone for attending. I appreciate it.
Thank you, guys.